Hello, Algebra 2 students. Today we are going to do 4.3 and 4.4 notes. We are going to learn about a concept called factoring. This is a skill that you learn in second semester of Algebra 1, and so we are going to do a refresher and add on to more stuff. The first thing I want to do is talk about some definitions. The first word is monomial, and monomial means one term. Okay, an example would be just a single number, like a constant, or a number with a variable that's still one term, or a number with a variable raised to a power. It's all one term. The next one is binomial. A binomial expression has two terms, and they are separated by an addition or a subtraction sign. So an example would be 4x squared minus 25. Another example would be 2x plus 1. Notice in each of those expressions, the terms are separated by a plus or a minus sign. And then the last type of term is called a trinomial, and it has three terms. Example, 2x squared minus 4x plus 1. Another one, negative 2 over 3 times x squared, that's your first term, plus, we're adding an addition sign, 5x minus 7. There are three terms there. That is a trinomial. Okay. A refresher, hopefully, is multiplying two binomials together. So remember, a binomial, bi means two, so binomial has two terms, and when you're asked to multiply them, you use a technique called FOIL. So FOIL stands, the F stands for first, outer, inner, and last. And it only works for multiplying two binomials. You can't multiply three trinomials using FOIL or four terms, so you can't do that. So let's go ahead and multiply this expression. So we are going to multiply the first times the first. So what I'll do is I'll label. So these are the first two terms in each set of parentheses. So that's your F. So we could just write it right here. Remember, x times x is not 2x. It's x to the second power. The outer terms are the outside numbers, so the far ends. So I just make a little rainbow there, and that would be x times negative 7, which is negative 7x. The inner, okay, I'm going to label it outer here. The inner would be these two inner numbers. Now remember, the 4 has a plus sign in front of it, so it's a positive 4. So 4 times x is 4x. And then finally, the last terms are the two last numbers in each set of parentheses, so these two. So 4 times negative 7 is negative 28. Then what you do is you combine the like terms. They could be in whatever order. In this case, these two are alike because they have the same variable raised to the same power. So your final answer is x squared minus 3x minus 28. Don't combine the x squareds with the minus 28 or so on, because they all have different variables raised to a different power. Now, the reason why I did multiplying binomials is factoring is the reverse of multiplying binomials. So we are going to take the answer from up above, the x squared minus 3x minus 28, and we are going to factor it. So that's the directions, factor it. So I'm going to write the expression, x squared minus 3x minus 28. Well, how do you factor it? Well, you know your answer is going to have two sets of parentheses. So here's the first thing you do. First thing you do is identify A, B, and C. So A is in front of x squared, B is in front of negative or x, and C is your constant that has no variable. This is why we learned how to graph quadratics first, because you know what A, B, and C are. You can learn how to factor so many different ways, but my students tend to love this method called the X factor. And so what you do is you draw an X, that, And then you put numbers on the top and bottom, but you're supposed to figure out the sides. So the number that goes on top is always what A times C is. And that's why I asked you to identify A and C. A is 1, C is negative 28. So multiplying those two together, so notice I put a dot there for A times C. The bottom number is always going to be B. Just think B for bottom. And I think hopefully that'll help you remember. And that's negative 3. Okay, so how are we supposed to solve the puzzle, the X, I guess? So what you do is you have to find two numbers who multiply together to give you negative 28. That's why I wrote A times C, but added together give you a negative 3. So here, added to give you that number and multiply to give you the top number. So you gotta be good with your number sense, I guess. And so I just think of numbers that multiply together to give me negative 28. I start with negative 1 times 28, negative 2 times 14, negative 4 times 7. But those same two numbers that you pick, they must add to get you negative 3. So I figured out what the two numbers were, and they are negative 7 and a positive 4. Because negative 7 times 4 is negative 28, and negative 7 plus 4 is negative 3. So that solves the puzzle. So you would write your answer like this. So your factors, you don't have to write the word factors, but you write your answer like this. X minus 7 times x plus 4. And that is it. So you just have to have a good number sense to find the sides of that x. And you can take your time, you can use a calculator or whatever to help you, but some of you are really, really good with your quick multiplication skills or addition skills, so it will really help you in this section. Okay, so here's some extra practice. So let's identify A, B, and C. A is 1, B is negative 6, C is negative 27. You can make your X as big or as small as you want. I have room, and for my notes, I'll write it a little bigger for you guys. Okay, so A times C goes on top, B goes on the bottom. It's negative 6, negative 27. Be really careful because you could miss a negative and you can't solve the sides of the puzzle. So whenever I think of 27, I think of 9 and 3, 9 times 3. Well, if I just put 9 and 3 here, notice 9 times 3 is not negative 27, it's positive 27. So one of those numbers is going to have to be negative, and that is determined by the bottom number. The bottom number is negative 6. Therefore, this number has to be negative. And your answer is x minus 9 times x plus 3. Or you could put x plus 3 and x minus 9. Doesn't matter what order you put the numbers in, as long as you list the x first. Right? Next one. A is 1, B is negative 12, C is 36. Make your X. And do you have to keep writing A times C? No, but I feel like students mix them up. As long as you remember B, the bottom number is B, you should be okay. So B is negative 12, A times C, that'd be 1 times 36. And then this one, the bigger the number is on top, the harder it is to try and figure out the sides. But when I think of 36, I think of 6 and 6, 2 and 18, and 4 and 9. Well, I know 4 and 9 will never give me negative 12, but I know 6's will. 6 times 6. 6 times 6 is 36, but 6 plus 6 is not negative 12. However, a negative times a negative is a positive, and a negative 6 plus a negative 6 is negative 12. So your answer there is x minus 6 times x minus 6. If you're lazy like me, you can write it like this because they're the exact same two numbers. So your choice. When they're the exact same numbers on the sides of the puzzle, you can write it using a shortcut. All right, next one, A is 1, B is 3, C is negative 10. A times C, that is negative 10. And B is the other number. That's why you need all three numbers. The smaller the number, the easier it is. So the only way you can get negative 10 is 1 times negative 10. Well, that never is going to add up to 3. 2 and 5, One of them has to be negative. So let's write the numbers first. They have to add up to give us 3, and the only way we can get 3 is if this number is negative, so negative 2 plus 5. And so your answer is x minus 2 times x plus 5. And you can go watch this video over and over again if you need to refresh. Okay, next one, A is 1, B is 11, C is 24. So these are your most favorite will be when A, B, and C are all positive. Then it's super easy. But it's not always going to happen where all the numbers are beautiful and positive. A times C, so that's 1 times 24. And B is 11. So when I think of 24, you hardly ever pick 1 and 24, but it does sometimes work. But 1 and 24 never add to give you 11. 2 and 12, 3 and 8. 3 times 8 is 24, 3 plus 8 is 11. Your factors are x plus 3 times x plus 8. You have to put them in parentheses and you have to put them next to each other. Some people put x plus 3 and then they put a plus sign or separate the parentheses. This is how you write your answer. So watch what I do and you want to follow by example. Well, what if you are asked to factor and you don't have 3 terms? If we look at examples 1 through 4, every single problem had 3 terms. You factored a trinomial. Well, the next 2 problems, notice x squared minus 36, that's just 2 terms. There's not 3 terms right there. So what do we do when that happens? Well, there's a special pattern, if I can figure out how to erase, and that is called the difference of 2 squares, and it only works. This has to be a minus sign. It can't be plus. And remember what squared means, something to the second power. So this has to be squared. Both of those. And how do you know? Again, you have to have number sense. The first one, well, it's easy. The variable has to be squared. But the last number, you have to think of what number times itself gives you that answer. Or think of square roots. So I teach my students this, and that really helps them. And I tell them, I'm like, okay, make your 2 sets of parentheses. Put in your variable first. The square root of x squared is x. And you put an x in each one. For the second set of parentheses, one has to be positive and one has to be negative. Because remember, when you multiply a negative number times a positive number, you must get a negative number. And that's where the difference comes in, this sign right there. Okay, so 6 times 6 is 36. But we want one positive, one negative, because a positive 6 times a negative 6 is negative 36. And that's all you have to do. Right? Second one. M times m is m squared, and the square root of 144 is 12. You don't want to put a 144 divided by 2. That's not what we're looking for. So one's positive and one's negative, and that's it. All right. The last one is a pattern, but honestly, I'm not going to show you the pattern because students try and take a shortcut and they get it wrong. 9 out of 10 kids get it wrong. Then you'll have one person who gets everything right, but that's just that one person. So I'm not even going to show you this pattern. We're just going to forget I even mentioned it. I've done it in the past, but it just doesn't work very well. So what I'm going to do, we're still going to do we are going to do the x factor. So A is 1, B is negative 10. Why can we do the x factor? Because there are 3 terms. Okay, I'll show you why it's called a perfect square trinomial though. Okay, so top number will be A times C, and bottom number will be B. So negative 10 goes here, 1 times 25. Okay, hopefully you will know by the name. It's called trinomial because there's 3 terms. I'll tell you how you get the name perfect square. So 5 and 5, 5 times 5 is 25, but 5 plus 5 is not negative 10. However, here we go. So our answer is x minus 5 times x minus 5. That's why it's called a perfect square trinomial, because you would write it like this. You're multiplying the same thing twice, basically. That's what you're doing. So that's why it's called a perfect square trinomial. But I'm not going to show you the pattern, so you can just cross it out and not even worry about it. However, do remember the difference of squares pattern. This is super important. Know how you get the word difference. The difference tells you to put a minus sign, or that there's a minus sign in the original problem, and you're going to put a one positive, one negative in your answer. Great. Okay, the second part of section 4.3 talks about roots. So another name for roots, so also known as zeros, they're also known as solutions. They are the answers or the solutions of a quadratic equation when one side of the equation is equal to 0. But one side must be equal to 0, or you cannot use the following property. So how do we go from factors to solutions? So the first page, all we did was we factored. In the second, these last 4 problems, we are asked to solve. So we are going to have to factor and then solve. And we are going to use this property called zero product property. I just call it ZPP. And it says that if you have factors that are in parentheses, at least one of the factors has to be in parentheses, then what you do is you set each of these. So you set this equal to 0, and you set this whole side, or this whole parentheses, equal to 0. And then you solve each equation. So you're going to have 2 equations. I tell kids to just make a smiley face, and that makes it easy for them. So notice that number 1 is already set equal to 0. It already is in factored form. So you don't have to factor anything on these, on numbers 1 and 2. It's already factored for you. When that's the case, I just say, hey, just put an equal sign and a z, like a smiley face or something, or you could put an equal sign and a 0. And so what you do is you write your 2 equations, x minus 5 equals 0 and x minus 4 equals 0. And then you add each one, or you solve each one, sorry. So the first one is x equals 5. The second one, you want to add 4 to both sides. It's x equals 4. So those are your 2 answers. These are known as solutions. So I would say, okay, what are your solutions? You would say x equals 5 and x equals 4, or they're known as x-intercepts, because if you graph them, you would graph 5, 0 and 4, 0. They're also known as roots, and they're also known as zeros. Same meaning. You're probably thinking, why do we have to have 4 different words to represent the same thing? Why can't we just call it answer? So it just helps you later on when I do ask you in this next chapter, I'm going to ask you to find zeros of a polynomial. So it just gets a little crazy. So you just need to know the different words. Okay, for the next one, it's already in factored form. 3m minus 2 equals 0, and m plus 7 equals 0. Solve each one separately before you move back and forth. So add 2 to both sides, divide by 3, m equals 2/3. For the second one, is so much easier. Subtract 7, and you already have your answer. So when you have to divide, it's just one additional step. So these are your 2 answers. Make it all pretty. Okay. Now on the last 2, notice they are not in factored form. So you must factor first and then solve. So how do you know it's not factored form? Because you have no parentheses. You can't just put parentheses around the whole thing. So it must look like problems 1 and 2, very similar. So notice the number 3 is already set equal to 0. And when it is, you can identify A, B, and C. A is 1. Remember, it's 1. B is negative 1. C is negative 42. Make your X, A times C, B. For me, it's so habit that I just like do it. I just habit. I just can do so many of these. So you put negative 42 on top, and B is negative 1. And like I say, the students have the hardest time. Those that struggle with number sense, they spend a little extra time making their X factor, but nothing wrong with that. There's no shame in it. Um, so here, negative 42, what two numbers multiplied to give us negative 42, and the same two numbers added give you negative 1? It would be negative 7 and a positive 6. Okay. So we have our factors. Now let's write it in factored form. X, notice it doesn't matter whether I put the negative 7 first or the positive 6 first. But now you have this equal to 0 because it's asking you to solve, whereas on the previous page, there was no equal. Okay, once you have that, then you can use ZPP. When you make like your smiley face kind of thing, that's called using your ZPP. So that would be x plus 6 equals 0 and x minus 7 equals 0. Subtract 6, add 7. And those are your two answers. Okay, and let us do our last one. So now this one's different. There's a y in there, but don't be scared because this is an example of a quadratic equation in standard form, and we learned how to graph it in the previous section. And when you see something like that, where the right side looks beautiful and the left side you see a y, you just replace that y with 0. And then identify A, B, and C. Or if you don't like it like that because you love to have the 0 on the right side, just rearrange. Or, just rewrite it so that 0 is on the right side. You can do that. So here, A is 1, B is 3, C is negative 28. I hope you've noticed something in all the problems we've done today about what A has been. Keep that in mind in every single problem. What has A always been? And I hope you're going to say it's always been 1 because that's a key. It's not always 1. And that's what we're going to talk about in section 4.4. What happens when A is not 1? When A is 1, life is easy, but A is not always going to be 1. So let's make our X. A times C, B, A times C, so it'd be negative 28. B is 3. So I know 7 and 4 go here, but now one of them has to be positive, the other has to be negative. Since 3 is positive, 7 must be positive. There we go. And so now we're going to write our factors. X, so we have x plus 7 times x minus 4 equal to 0. Since you have an equal sign, you know you're asked to solve. Write your two equations, and then subtract on this one, on the lefty side, and add on the other one. And those are your two solutions, or zeros, or x-intercepts, or roots, all meaning the same thing. And that is the notes for 4.3. Have a great day.